In this video, I'm going to give you some tips for solving the ALEKS problem called applying like dissolves like. Like dissolves like is a term that chemists use to help us make predictions about whether or not a solute is going to dissolve in a particular solvent. In this phrase, like dissolves like, the terms like and like are both referring to polarity, meaning that polar dissolves polar and nonpolar dissolves nonpolar. In general, so as a general rule, if we have a solute that is nonpolar, as you probably know, that nonpolar solute is going to dissolve in a nonpolar solvent. If we have a polar solute, it is going to dissolve in a polar solvent. And then also in this problem, we are going to see some ionic solutes. Ionic solutes also dissolve in polar solvents. So even though this is a relatively straightforward concept, just matching polarity up, of course, ALEKS is going to find a way to make this problem as tricky as possible. In this problem, you're going to have three sets of problems within every single problem. There's going to be one solute, and it is going to be paired up with two possible solvents. One of the solvents is polar, one of the solvents is nonpolar, and so we have to match up this solute with the appropriate solvent based on polarity. So one part, we have to classify our solute as being either nonpolar, polar, or ionic, and then also we have to classify the two possible solvents. Once we get that done successfully, then we can just match up appropriately based on the relative polarities. Now, the way that this problem becomes really tricky in ALEKS is that they are going to give you a variety of different solutes and a variety of different solvents. So it's really difficult for me to kind of give you a general sort of rule of thumb about how to approach this problem. What I'm going to do is begin by talking about the potential solvents that you might see on this problem. And I don't know every single solvent that you could possibly see. So please be patient with me if I'm not listing every single one. And what I'm actually going to list are the polar solvents, because there are not as many polar solvents as there are non-polar solvents. All right, so I'm going to list polar solvents that I have seen popping up in this problem. Water is one of them. I've also seen ammonia, NH3. I have seen acetic acid, which is usually written as a Lewis structure, kind of looking like this. We know that it's all of these we know are polar because they have NH or OH bonds. I have seen acetonitrile, CH3CN. I have seen acetone, CH3CO, CH3. And I have seen its cousin, DMSO, CH3C double bond S, CH3. And I have seen a variety of alcohols, methanol, CH3OH, ethanol, CH3CH2OH, and then propanol, CH3CH2CH2OH. And also I have seen, I've seen dimethylformamide, so this guy, CH3N, CH3, C double bond OH. And so these are the different polar solvents that I've seen as I flipped through. I flipped through probably about 15 versions of this problem. Don't try to look necessarily for patterns with these polar solvents. So for example, this, you might be tempted to kind of recognize that OH, all these OHs mean polarity. Not necessarily. If you stack more carbons onto this pattern, so if you had a CH3, CH2, 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 OH, that's not going to be a polar solvent. And so these are the polar solvents that I saw. The other types of solvents that I've seen on here, they've all been non-polar. And we're not going to make a list of those because there's way more of them than this. Okay, so looking at these possible solvents that we see here, I see water. That is a polar solvent. I'm just going to write a P. This one is a non-polar solvent. With these, again, one of your possible solvents will be polar and the other one will be non-polar. So if you can get one of them classified, you're going to know what the other one is. And then over here, we have the tricky job of figuring out what our solute is in terms of polarity. So it would be awesome if your solute was one of these guys. That would make the problem relatively simple. And I have seen that on some of these versions. The solute was one of these things. But most of the time, the solutes are going to be an entirely different molecule that you're going to need to classify as being either polar or non-polar. So we're going to kind of make a list of that, of what we're looking out for there. Polar solutes These are going to be molecules that have OH bonds in them, and they typically are going to have a lot of OH bonds in them. They are going to have, I'm trying to flip through some more different examples so that I can see some more examples for you. They are going to have carbon-oxygen double bonds in them. They are going to be ionic compounds. So that would mean that they have a metal plus a nonmetal. And ionic compounds are usually pretty easy to identify because the ionic compound is going to be written as a formula. It's not going to be drawn out as a Lewis structure. So you're going to see a formula for ionic compounds. Although be careful, because I have seen some things that are written as formulas like Br2. I've also seen I2. These are not ionic. This is not a metal with a nonmetal. These are just a couple of nonmetals. These are nonpolar. This problem is it's just pretty rough. Okay, so looking at this first molecule here, I don't see any oxygens at all. I don't see any OHs. I don't see any carbon-oxygen double bonds. Also, with polar solutes, we could see some NHs, or it could be like an NH2 or even an NH3, but it's just some sort of NH. We'll just say NHX on there. So we don't see anything that gives us indication that this is polar. So that means that this thing is probably nonpolar, and that would make the first solvent here the best solvent of choice. Here's another one written in a molecular formula as opposed to a Lewis structure. That means that it is probably ionic. And we're going to analyze it a little bit more carefully. We can see that we have a metal, calcium, with a nonmetal, so that means it's definitely ionic. That makes this polar. What kind of solvents are we working with here? Ooh, look at this guy, CH3OH. That is one of our polar solvents, which makes, by default, the other one is nonpolar. So we're going to pick the polar solvent because we're trying to match up the polarity with the solute and the solvent. I do have one more. There is always going to be a third one on here. Here's another one. Written as a formula, not as a Lewis structure, metal with a nonmetal. That makes this polar. What are my choices here? One of these solutes is, or solvents, one of the solvents is polar, one of the solvents is nonpolar. Let's kind of reference back to that list. CH3OH, that is one of the polar solvents. And remember, I told you, don't just pay attention. If we're talking about the solvents, don't just pay attention to the OH. There's a limit to how many carbons you can have associated with that particular OH. So that this solvent is not one of the polars. That means that this CH3OH would be the appropriate solvent for NaCl. In general, this problem is actually quite unpleasant. And the reason for that is because there are so many different possibilities of what you're going to see as solutes and what you're going to see as solvents. And like I said, hopefully I've given you an all-encompassing list of the polar solvents that you might come across. The polar solutes, even a lot trickier for me to give you a list of the polar solutes because there's even more variety there. A solvent that's not on this list is probably nonpolar. A solute that doesn't meet one of these characteristics is probably nonpolar. However, you have learned, if you're working on this type of problem, you have learned how to identify polarity and nonpolarity by looking at the Lewis structure of a molecule. So it probably would be helpful, if you're getting this problem wrong quite a bit, it would probably be helpful to go back and reference how to classify a molecule as polar or nonpolar. I do have some videos of that. This would be stuff that you learned pretty early in Gen Chem. And just, good luck. This problem is pretty rough. And, yeah.